Fourth day of this Gyan course. Today, primarily, I will be talking on implementation of finite difference for option pricing problems. Uh, so let us quickly recap whatever we have done. I hope I'm clearly audible. So, yeah, yeah. So, thank you. So, what we were doing in the last lecture that uh, we discussed actually in last two lectures, we discussed in detail this numerical methods for heat equation, right? So the idea is simple that we took a heat equation and then we solved it using finite difference method, that is called forward Euler method. And why we did so using forward Euler only? The reason was simple, that it is simple to use. Okay. And then we realized that how to do it. We wrote the discrete version of this equation, and then by putting the different values, we wrote it, right? We did it. But the question was simple, that who guarantees that whatever the solution you are obtaining, this is correct? That is the big question. I mean, whatever you are doing, who guarantees that it is correct? So then we discussed a few theoretical aspects, that yes, there are three aspects: consistency, stability, and convergence, and which guarantees that yes, whatever you are doing is correct. Whatever, if our numerical scheme satisfies these properties, then whatever the value we are going to get, it is correct. So we read the definition of consistency, stability, and convergence. I gave you one book, also provided you the link of one book for numerical method and one book for MATLAB, both. And then this is where we winded up by looking into three types of finite difference schemes. I think from here it is clear that if we are using on the right hand side only n, then it is forward Euler. If we are using this, like if we use on the right hand side n plus 1, that means if we are getting this kind of a scheme where we need to do inverse, then this is called backward Euler scheme, and combination of both, actually it is trinomial. So we also discussed that why do we need these three? Because not only three, we need maybe more. The reason is simple again, that no scheme is perfect. Okay. So now let us quickly move to our next lecture. So the idea is that today we will do implementation in MATLAB. This is our first priority. Before that, I'll just discuss quickly a few things, right? Because we want to do the we want to do Black-Scholes finite difference method for option pricing PDEs. So let us start this. This is lecture 5, or maybe whatever you say, right? Lecture 5. So the idea is that the first question is why Black-Scholes has analytical solution. Why Black-Scholes PD, right? Black-Scholes PD we read, right? Black-Scholes PD has closed form solution, and we read also its solution, that what is its formula, right? Black-Scholes formula. But I mean, what I said earlier, I said that Black-Scholes has closed form solution, so you can directly find the uh, value of option price from there. But for other PDs, you have to rely on numerical math, because other PDs do not have this closed form solution. So the reason is simple. Reason I must tell you that what is the reason that why it has closed form solution, right? So let us take uh, the Black-Scholes equation. What is the Black-Scholes? Okay, so okay, fine. Sorry, yeah, I just forgot. Okay, fine. Yeah, sorry, I just forgot. Now I think it is visible. Yeah. Okay, so the question is why Black-Scholes equation has closed form solution, and then we will move towards the numerical methods. So let us quickly understand that what we have the Black-Scholes equation, del V by del T plus half sigma square S square del 2V by del S square plus RS del V by del S minus RV equals to 0, and then with some initial condition, right? Vt comma S equals to S minus K plus something like that. So the question is simple, that we are looking why it has closed form solution. So the observation is simple, that if we take transformation, this can be transformed to heat equation. This is the basic idea, right? This Black-Scholes equation. So what Black-Scholes did actually, they derived a partial differential equation, but then they transformed it into heat equation, and we all know that we can find the we can solve the heat equation on pen and paper, and this was one of the major advantage, right? This was one of the major advantage of Black-Scholes equations, that they could solve it using uh, pen and paper without doing any computation by transforming it into heat equation. So let me tell you, I'll not tell many transformations. Let me tell you quickly. So what the transformation of variable, you know, right? We will convert from v to u, etc., etc. So they took the first, they took x equals to log s, right, and tau equals to t minus t. So if you take simple, these two simple transformations, right? Simple. So what your equation becomes? Del V by del tau minus half sigma square del 2V by del S del x square. Now it becomes in x minus R minus sigma square by 2 del V by del x plus RV equals to 0. And then now our equation becomes 0 comma x equals to e to the power x minus k. Only thing I wanted to tell a few things here. The idea is simple, that what is the difference in equation number 1 and equation number 2? Can you quickly recall? I'll wind up with this in only 10 to 15 minutes, right? And then we'll go for MATLAB implementation. But I felt that this is important, right? I felt that this is important. So can anyone tell quickly what is the difference in these two, equation number 1 and 2? Actually, here the coefficients are variable. Variable coefficient P. Why? Because here it is S. You see, here it is S, and S is variable, isn't it? Our S and T are variable, right? V is depending on S and T. Here V is depending on X and tau, but there is no X, there is no tau here. You see. So this equation is constant coefficient PD. This is one thing we learned, that yes, by transformation we can convert this Black-Scholes equation from variable coefficient to constant coefficient PD. And this is called convection diffusion equation. Why? Because there is a second derivative term also and first derivative term also. So I hope everyone is comfortable till here, that yes, actually I'm just giving you intuition that you can, this question may arise in your mind, that okay, for Black-Scholes we could find exact solution, for other PDs why we could not find? We can. So we must understand that reason, that why we cannot find for other. PDEs, other problems, right? So then they said that you take another variable transformation. What the transformation we took? Second. So please try to understand. Second transformation, v equals to u e to the power alpha tau plus beta x. A bit complicated. I mean, they got Nobel Prize for it, right? So it must be very beautiful and very standard, right? And they did using this equation, right? They find del v by del tau, del 2v by del x2, del tv by del x. They did all this and after some simplification. I'm not going into it, right? I just want to give you the crux. After some simplification, right? They got this beautiful equation. Del u by del tau minus sigma square by 2 del 2u by del x equals to del 2. How beautiful it is. And this is what? This is nothing but our heat equation. Yes. So from here, you got this equation number 3. So I hope this is clear to all of you that the simple reason is I see lots of mathematics is involved here, right? Please do not think that this is too simple. No, of course not. So lots and lots of mathematics is involved, but what I tried to give you that the derived equation number 1, right? Let us not take this is let us take one AB, right? Otherwise you may get so Black's holes, they derived equation number 1, they transformed it to equation number 2, then from 2 to 3, right? They from 1 to 2, then 2 to 3, and then they obtained here now the heat equation, and then they know the basic idea that, oh, heat equation, they can solve it. This is a Cauchy problem using the fundamental solution, etc. So we will not go in that. And they solved it, this heat equation, and they found that our price, so here they will get, if they solve, they will get V, right? But from the V, they can, using the transformation, sorry, pardon, they get U, because it is the equation in U, right? And from that U, they will transform it to V, and they obtained V of S comma T equals to S of N D1 minus K e to the power minus R T minus T N D2. This we have already discussed. So this is how I just wanted to give you a very brief idea that how black holes got the exact solution. Now, imagine if you have any other PDE, you may not be able to convert it into constant coefficient. Or even if you will convert it into constant coefficient, you will not be able to convert it into heat equation. And that's why for other problems, you are not able to get closed form solution for option pricing equations. I hope I'm clear till here. The idea is simple that I just wanted to tell you that why this black holes PD, the closed form solution for black holes PD existed. The reason is simple that they could convert it into heat equation, and that's why this analytical closed form solution can be obtained. Okay, now let me and now this is the reason, please try to understand, this is the reason that black holes can also be converted into heat equation. So what we do, we can solve this heat equation and convert back to the problem of option pricing, right? So I'll stop here this theoretical part, right? Now we will go for hands-on, right? So in this whole course, we read many theoretical aspects, right? We started with options, we understood option clearly, then we understood that how black holes PD came into the picture slowly. And then if we have any, and then we saw a beautiful figure that it says that it is not only black holes PD in option pricing, we have lot many equations, partial integral differential equations, partial system of partial integral differential equations, etc. then we realized that all of them don't have analytical solution, right? So we have to go for numerical solution, right? So then for numerical methods, we started finite difference method for heat equation. We implemented it on pen and paper first. Later on, we will go for MATLAB, right? And then we realized that yes, uh, who guarantees that whatever you are implementing, it is going to be it is going to give you the accurate results, right? Who guarantees? So then we realized that yes, there are theoretical aspects, consistency, stability, and convergence, which are going to give you the guarantee that whatever you are doing, it is going to give you the accurate results. This is done. And now, once we are done with those methods, and we also understood today that why Black-Scholes equation has analytical solution, why other PDEs do not have analytical solution. So kind of fortunate enough, they were fortunate enough, I would say, and they were of course intelligent enough, right? So that they realized this beautiful property that, oh, we can convert it into heat equation and we can find its exact solution, right? So it is important. Okay, so now I'll just quickly ask everyone that how many of you are comfortable in MATLAB? Because now I think I should go for some hands-on. This whole lecture will be based on hands-on. So we'll go from the very basic, right? And if you feel that it is too trivial, you can let me know. Or if you feel that it is too complicated, then also you can let me, right? So let me share the screen and yeah. So just letting you know about MATLAB. So it is a software, simple software to do the computation, right? So what you do, you simply create you simply write some codes to solve certain equations, linear, nonlinear, whatever, right? Nowadays, this becomes so powerful. MATLAB became so powerful, and so how many of you? I just want to know how many of you have used MATLAB earlier? Jai Kishan, Manohar, Pooja, Rakesh Yadav, Sri Hari, Sarthak, Sivangi, Athav. How many of you? Just can you tell? No, okay. Others? Anyone? If you can tell, have you used? So let me tell you a few more things. That MATLAB requires license, right? It is a not free. It is costly software. So if you people feel that you don't have MATLAB in your institute, there is something called Scilab, which is open source, which is freely available that you can use. Most of the features in MATLAB and Scilab are same, right? So there you can try. Okay, this is one thing. Second, if you have MATLAB on your in your institute or you want to do some coding, so we'll see here that how we do coding in MATLAB, right? So whenever you open MATLAB, you get this kind of visual, right? All of you can see this, right? And just 1 minute, yeah, right. So I hope this MATLAB is visible to all of you. So here, what we do, if we have written some codes, we can open that file, but I'll not first open that file. I'll just create. So how to start? If you have to start, let me close everything. So it looks like this. So I'll be going through the scratch, right? Those who are comfortable, they can simply recap. It's not that they can ignore. You can simply recap, right? Everything is, and then if you are not comfortable, if you have not used ever, then you can understand it. So the idea is simple, that you can simply write here also that a equals to 3, so and b equals to 5 and c equals to a plus b, right? So why we put this colon, semicolon here. If you do not put semicolon here, what will happen? It is giving you the value there only, right? If you put semicolon, that means we restrict that, okay, you store it. And you please see here, okay, let me see. So this is your workspace on the left hand side, you see here, right? And here the files are there, right? Here the whatever in which directory you are. Directory means from where you want to import your files, right? So so you just forget about files as of now, because some of you might get confused, but workspace is important. What is workspace? That if you take a equals to 3, you see here a is stored here and its size is also stored. It's one by one. Suppose you want to define a vector. How will you define a vector? 1, 2, 3. So now you see here 1 cross 3, 1 row, 3 columns. Agree, everyone? So, Jai Kishan, I hope it is comfortable to you because you have not used MATLAB in your earlier time. So, is it okay? So, what we are going to do, we are going to understand a few basic commands in MATLAB first. Then I'll explain you a code, how to write a code for heat equation, right? This is our target. If you feel that something else to be done, please let me know. Anyone having any comments, he can tell that what I should do. But I believe that this is a good idea to do this, right? So we are going in a very basic way. So V is stored here. So, but if we want to write a big code, so then how will we write here? Then what is suggested that you click here on new script, right? And here you see it comes like this. Okay, so suppose this percentage sign is basically whatever you are writing here, that will how to write a big matrix. Yes, I'll be telling you. Good, good. That's why you can ask, simply ask, right? Very good. So suppose some introduction to MATLAB commands. What does it mean? That this file is having introduction to MATLAB commands, but when you run it, it is not going to give you, it will not consider this command. Okay, let me tell you. So, but if you want to run it, it will first say that you save it because it is not saved. This star mark here, it clearly shows that it is not saved, right? So you can simply first of all save it. Before running, you simply save it, and then you can save wherever you wish. Suppose you want to save it on desktop. So you whatever the name you want to give, you can give. And here you see the type, all the type file, MATLAB file is .m. So whatever file you will save, it will be saved as .m. So MATLAB intro.m. So the compatible, I mean the extension for MATLAB files is .m. Okay. So now it is saved, you see, and where it is saved? On the desktop, it is written. Okay. Now, Jai Kishan said that how to store long matrix. Okay. So, okay, something is suggested by AI. So let us see this, then we'll come to it. So it is already suggested by the AI. What it will give? Can anyone guess? So if suppose I have typed this and then simply you can run. And let me tell you one thing, that we use usually these two commands. What it is? CLC means you clear everything on command window. What does it mean? If you see here, excuse me, yeah, sorry. So CLC means you clear the command window. See, you write here anything, a equals to 1, b equals to 5, c equals to 9, but now you see that, oh, so many things. So you want to clear the command window. So what you will do? CLC. That's it. So it will clear the command window. But now you want to clear the workspace. Whatever the variables you have already stored, suppose they are not of your use. I mean, now you don't need this ABC. So what you will do? You simply type clear. Can you see? All the variables from workspace is gone. Okay, so whenever we start a code, it is preferred to use these two commands. Why it is so? Now we understood that. Why it is so? That, just a minute. Why it is so? That we don't want anything on command window and as well as in workspace. Because see, if suppose some previous values are stored unnecessarily, they will take our space, they might create some issue, right? So no need to store the previous values. What he's saying? He's saying that simply you can remove it. And it is one simple command. You just put CLC and clear, it will be done. Now, suppose I have written this, welcome to MATLAB. Here are some basic commands to get started. Okay, if I'll run it, right, what it says, welcome to MATLAB. There are some basic commands to get started. What does it mean? That this command is used to print anything. If you want to print, if you want to type here in command window anything, this will be, we will use this. So suppose we want to display this. This means display, right? So this one, what is one? Help, display help information for the function. What does it mean? What I'm saying? That, right? So many things now it has started. So whatever we want to display on command window, we can write here in this. But one thing we have to realize, that this does not do anything. Because why? Because we have used this percentage sign. So what this percentage sign is? Percentage sign is simple. If you use percentage sign before any line, that means MATLAB is not reading these lines. MATLAB doesn't bother about these lines. Okay? MATLAB doesn't bother about these lines. Suppose you comment all. We say that we are commenting it. Suppose we comment everything, nothing will happen. Just nothing is happening. Right? Nothing is happening. So now what you asked, so here what he was saying, that you simply press Control Shift P, right? And you can write here, write a code to store a large matrix. You see, it has generated. But believe me, it was not there when I was, I mean, earlier, like when this Copilot was not there, right? When this Copilot was not there, then this was not. So if we want to generate, I'll tell you, of course, how to write view, right? So this here, he has generated that. What you do, you take rows, right, 10,000, you take column 10,000, and then they created a matrix. Its name is, suppose, A. Its name is A, right? Its name is A. And what is this random, RAND? What is this function? So we will discuss here in detail that MATLAB has so many inbuilt functions. What does it mean by inbuilt functions? Just like this rand. Rand is what? So suppose you want to know about rand. Rand is basically generating random values, but suppose you don't know about rand. Then what you will do? So rows you have defined, column you have defined, A is this, right? And then A you are generating and you run it. Run it. Right? 10,000 by 10,000. You run it and you got this. Just 1 minute. Why it got? Yeah. So the idea is simple, that it will take some time. He's saying, you see here, 10,000 by 10,000. Matrix is stored here. Columns, how many columns? 10,000. How many rows? 10,000. Agree, right? Now the question is, suppose you don't know about so when this sign comes, that means the process is over. That means the process is over. Now you can simply run the other command. Now what you did, but you can say, oh, I cannot see a matrix. Where is the matrix? You can say, where is the matrix? I cannot see the matrix. So what we did, we created a matrix and we saved it. Why? He has written beautifully here. Suppose this matrix we want to use later on. Suppose we want to use this matrix later on. So we have saved this matrix, and where it is saved, you see here, this large matrix. This is the name, right? Large matrix dot mat. Agree? So this we can load it. So wherever we need, we will load. So how we load it? We simply use this command and we load it. That's it. Okay, so what we understood from here, that how to start a code, why do we use this CLC clear, how to define a matrix. You said that, and now one question is still pending, that I don't know this rand, what it is. So what we'll do, we'll simply type help and space and then the command name, the function name. That's it, nothing to do. No need to go to Google or ChatGPT to let us know that what is RAN, right? So MathWorks gives this facility that suppose here the RAND is used. So what is RAND? So we see quickly what it is. It is saying that it gives you uniformly distributed random numbers, right? So let us understand it in more clearly, right? That what is RAND. So let me just comment everything, right? So that you can, this example I should have taken little late, but since you asked, that's why I have taken. So now you see, suppose x equals to rand 5. What it should give? Can anyone quickly tell? So here you see, here you have cleared everything in the command window, you have cleared everything in the workspace. But you see, in workspace, X is coming. Why? Because X you have defined here, right? So previous things are cleared. Now whatever you define, that will come in the workspace. So it is coming 5 cross 5 matrix. So what is X? We'll type here X and we'll enter. It will give you. You see, rand 5 means 5 cross 5 matrix it will give. Good. Now, but important question is what? You please see the entries 98667229. Now again I'll run and then again I'll type X. Entries are changed. So what did we get from this? It is random number, right? It is what? It is randomly generated. They follow uniform distribution. I'll not go in that because most of you might not have done any course on probability theory, right? Or you might have done, I'm not sure. But what we realize that again the number is changed. What we'll do? Again we'll run. Then we'll print X. Again the number is changed. So yes, it is giving you. So now we'll simply read, right? That it is giving you random scalars, and from where they are coming, from 0 to 1. It's not like, you see, all the numbers are between 0 to 1. Okay, all the numbers are between 0 to 1. I hope till here it's fine to everyone, right? That what we understood, that yes, in MATLAB there is something called workspace. So workspace stores all the variables. This is a command window, right? Command window gives you, whenever you run something, it gives, actually shows you the results, right? This is one thing. This is a script file. A script file means basically this is the file. So what does it mean by file? Let me show you. So okay, so what you did, you created a matrix. 1000 10,000 by 10,000 is too large actually, so let us take 10 by 10 just to show you, right? And then you saved it, done, and then you closed it. And later on, when you opened, right, you said, I again need that 10 by 10 matrix. What should I do? So this is the idea. What is the idea? You simply go on open, you go to desktop, right? And you see here, 3 files are there. You please see, everyone. Are you able to see? No, I don't think so. Are you able to see this open command window? No. Open command window, are you able to see? I don't think so, because if you click on let me share the whole screen. Yeah, so now it is fine, right? So what we'll do, suppose you said that I'll need the previous code what I did, right? So what you'll do, you simply go to open, right, and you go to desktop. Please see here, I just want to show you a few things, beautiful things. That MATLAB intro file which you wrote, right, which you wrote 4 5 lines just now I wrote, that is only of 1 KB. But the matrix you created, and you see the file difference. This is MATLAB code, this is MATLAB data. All of you, I request everyone, just please see this carefully. These are small things but beautiful things, right? So this is data. Data means you created some matrix, some variables, some files. So that is data. Code is what the code you are writing. Okay. So how large it is? It is very large. 7,38,881 KB. So that means MATLAB needs this much space to store the 10,000 by 10,000 matrix. I hope I'm clear, right? MATLAB needs to store 10,000 by 10,000 matrix. So I want to utilize the previous version. So simply I opened this MATLAB intro and I just clicked on open, and now it came. Right, everyone? So then we can simply run it, and we can again get what large matrix. So here, what is that variable large matrix? We'll type it here, large matrix, and this is 10 by 10 matrix we got. Kishan, I hope it is clear that how to write large matrix. Of course, there are other ways. That suppose you know the entries, right? Then you can use the for loop or while loop. For loop you can use it. Okay, so I hope this basic things are clear to you. So let us quickly do a few more basic commands, and then we will move to the, or let me now go to that uh, backward difference formula, right? Otherwise, I mean, because there. So now next, what we are going to do? We are going to do how to write code for this backward Euler method for heat equation. So what we are going to do? We are going to work on backward Euler method for heat equation. And I will share this uh, file with all of you participants, right? So that you can, I mean, understand it later also. You can work with it, you can play with it, right? Agree? Agree. So now let us quickly try to understand this code, because if you will understand one code at least, then I mean, at least my job will be over, right? Yeah. So this is the code for backward alert, and let me share the screen. Yeah. So we share the whole screen. So please try to understand that we are going to do the backward alert, right? We are going to do the backward alert. I discussed yesterday why backward alert, because forward alert we have already done, right? And backward alert gives, I said that pretty good results. So let us quickly recall forward alert, backward alert, and Crank-Nicolson. You please see here, and I'll be sharing with you all three this all three codes: forward alert, backward alert, and Crank-Nicolson, all three codes. Okay, right? So what is the key idea? Key idea is that we will discretize the equation, but in this way. All of you able to see, right? What is the way? That Vn plus 1 minus Vn upon delta t equals to, on the right hand side, it would be n plus 1, not n. And then when we put value of k equals to 0 and k equals to 1, k equals to 2, etc., what kind of matrix form we get? This is important. Everyone please pay a bit of attention here. I request that if forward alert you do, you get this kind of matrix. But if you do backward alert, you get this kind of matrix, and then you, for solving it, you need to do inverse of A. And in MATLAB, this represents actually basically for the inverse command. This slash is basically for inverse, right? So what we are going to do, we are going to solve the heat equation by MATLAB. So do you wish me to to spend some more time on basics, or should we spend some more time on this code only? Maybe on this code only, so that you'll realize, right, that okay. So now, okay, so let me first try to yeah. So this is the code for backward, right? So what we realized, that we have share the whole screen, because many times I need to change. Yeah. So now you can see the whole screen. So yes. So what we realized, I'll share it here. Right. What we realized, that we need to solve ut equals to uxx, right? Our exact solution was e to the power minus pi square t sine pi x. Everyone, our initial condition was sine pi x, and our boundary condition was 0. That means what? And x, suppose we are taking from 0 to 1, and t we are taking, suppose, from 0 to 0.1. That's it, right? Everyone, okay? So this is the equation we want to solve. Let us try to understand one code at least clearly, so that you all are comfortable. So this equation we want to solve. Let us quickly understand the backward alert method. We are trying to solve it using backward alert. Right. So let us try to understand backward alert quickly. What we did, what I said, that what we need to do, that you take this as Vn plus 1 minus Vn, right, upon delta T equals to Vn plus 1 k plus 1 minus 2 Vn plus 1 k plus Vn plus 1 k minus 1 upon delta x square. Okay. Okay. So now when we do this, we get this kind of system of equation that a u a v n plus 1, just a minute, we get a v n plus 1 equals to v. So if we want to solve vn plus 1, what we need to do? A slash vn plus vn. Right? This is what we need to do. So we realized here that what we realized? We realized here that we have a equation, heat equation. We want to solve it using backward Euler method. And how do we solve it? This is the way we have to solve it. Now, we will understand MATLAB code for this, or I mean, we can write it also, but since I have written, I just want to uh, explain it line by line. It may take some time, but at least you will understand one code, so it will all be clear to you, right? So please try to understand that why we are writing this in comments, because later on if we open, please note this comment, writing this comment is very important, because after 6 months when you open this file, you won't be able to remember for which reason you have written this code. So all of us should clearly write here that what word Euler numerical method for solving, right, solving heat equation. So what does it mean? It means that clearly that whenever later on, only one comment, it's not only 3 4, so you can write 3 4 comments also, no need to worry, right? But one comment is sufficient. Please try to understand that uh, whenever later on I'll open, even after 1 year, when just I open this file, and it will clearly give us that, oh, this code is for solving the heat equation. Because if you are a research scholar, or if you are a BTech student or anyone, right, you need to write, nowadays you need to write many codes, right? Hundreds of codes you will have in your laptop. So how will you identify that which one is for what? Okay, how will you identify? So this is the idea that please write these comments very carefully in each code. And then one more thing, what we do, we usually write readme file, right? So wherever, suppose we saved 10 MATLAB codes, and there we create a readme file. That readme file tells us that, okay, this file is this file is this. So you don't need to open all the files. So suppose I'll just show it here, right? So suppose I have written, you see, I have written so many files, right? But later on, if you see, I may get confused that, oh, which file is for this, what file gives us. So what we do usually, we create here a text file, right? Text file, simple text file, and this we call it readme. All the students, I request everyone that this practice you must follow, right? So here in readme, what we do, we simply write that, okay, this first file, what is that? New backward, right? This is giving me this is basically backward Euler method, right, for heat equation. Then second, so what did you realize? What is the benefit? You don't need to open all the codes, and all the students, you should follow this. Otherwise, believe me, it will be huge chaos at the end, because nowadays we need to write one code each day. It's very nowadays, like all those who are in who are doing an engineering degree or an PhD, right? So please do write this readme. So now try to understand. So whenever I went to this folder, I am confused that what it contains. I just opened this readme. Its name is readme. I mean, basically readme, right? So I just opened this readme and I got to know that, oh, all these files are for what purpose. So all of you, I strongly suggest that this practice you all should follow. Okay. Now coming back to this, we done. So, and in the code also you should write the very first line about that particular file, that what this particular file is doing. Okay. So till here I think it's I'm comfortable. I mean, clear enough. Okay. Now, next we are using three commands here: CLC, clear, and close all. So CLC and clear we have already noted down. That why do we use that? CLC is just to clear the command window. The only reason is for clarity. It's not anything it is going to harm you. No, if something is written here in the command window, it's okay, right? Suppose y equals to 4. It's okay. It doesn't take anything, but it takes two problems. It creates two problems. What? That something is written here, so I may get confused. And second is that it is stored here in workspace. This is a problem. Why? Because it is taking some space, right? It is taking some memory. So if something is not of your use, why? Just remove it. Okay, so that is why we use clear. Okay, that is why we use clear. So now whatever the memory MATLAB was using from our PC, it is done. I mean, whatever the memory used by variables, that is gone. Now no variable is there, so no memory is utilized by the workspace. I hope it's clear. So clear, CLC and clear is perfect. What about close all? Now, why close all is important? So let me discuss. So the idea is simple, basically, that suppose you have written one code and it is giving you some figure, right? And then you run another code, it is giving you another figure, but you are confused that which figure is for first, which figure is for second. Got my point? So I have these two codes. I ran this code, I got a figure. I ran this code, I got a figure. But now I'm confused which figure is for first one, which figure is for second one. It may happen. It's not it always happens. Those who are expert, those who are good enough in MATLAB, I mean, they do some access labeling, etc. So it is not for confusing for them, but at least those who are newcomers, for them it is strongly suggested that you use the command close all. What does it mean? That it closes all the figures opened previously. So that means whatever the previous figures were there, they were closed. No need to worry. Now, so now you see these three commands. Beautiful, right? It clears command window, it clears workspace, and it closes all the figures opened earlier. So till here, I hope I'm clear. Can we generate two or more figures? Yes, we can generate. I'll show you. Here you see three figures. 1, 2, 3. So let me run it. Okay, no, I'll not run it now, because I mean that will be just blind, right? You don't know anything and we are running the code. So Jai Kishan, we are going to do this. Is it okay? So that's why I have taken this code, so that this code will clarify your MATLAB doubts also, and at least you will have one code which solved heat equation. And heat equation is nothing but you can transform Black-Scholes equation into heat equation. So the key idea is, if you know how to solve heat equation, you can simply solve the Black-Scholes equation also, and That's not very difficult. Okay, I hope I'm clear. So next is input the, so usually in differential equation, x variable, so let me here explain it so that it will be clear to you. So the idea is that usually we have two variables here, right? U is a function of x and t. Use a function of x and t. So please try to understand that this variable we usually, it is a terminology, right? So we call it space variable, and this variable we call it time. Everyone understood? So we say x as a space variable and we say t as a time variable. Okay, now question is you want to solve heat equation. You want to solve heat equation, but the idea is that what the range you want to take for x and what the range you want to take for t, that is important. So what the range we have taken here, 0 to 1 and 0 to 0.1, but this will not be fixed always, isn't it? For different PDEs it will be different, or maybe you want to change for same PD, you want to solve it for not for 0.1, maybe for 0.2, t equals to 0.2 you want to solve it. Then what you will do? Right, then what you will do? So either, please try to understand this command, the very first command. Right, I'll comment everything, otherwise it may create confusion, right? I'll comment everything. So this first command, a equals to input, enter the lower limit of space variable. What is space variable here? X. So basically enter the lower limit of x. Okay, so if I run it, it will ask enter the lower limit of space. What was the lower limit of x? I'll enter 0. That's it. Because x was from 0 to 1. What else we could have done? We could have simply given a equals to 0 here, and that's it. Why to do this? And if I, so here a is 0, right? You see here workspace, a is 0. And if I directly put a equals to 0, then again also a equals to 0. So I want to explain why did we use this input command. Right. So this is basically writing a good code in general, right? Suppose there is a PD, Jaikishan wanted to solve it. So Jaikishan wanted to solve it from 0 to 1, and then suddenly some other person came, right? And he said that, okay, I'll solve it from 0 to 2 or -1 to 1. So he has to change the value here. If it was 0, then he has to change the value here. But if I use this, then there is nothing to change. If you run, suppose Jaikishanji ran. So Jaikishanji entered here 0, and suppose Vidyadhar Sahu ran. He entered here -1. That's it. So did everyone realize I've used input command instead of giving directly the value 0? So this input command is more general, right? This input command is more general. Whosoever wants to use this code, they can use it. I hope I'm clear till here. Right, everyone? Okay. So it is 1 hour, and you also may need a break of 5 minutes maybe. And so